When you are dealing with antennas, you may have heard about the gain in dBi and gain in dBd. So in this video, we can explore more about what is meant by gain in dBi or gain in dBd. We know that antenna is a passive device. That means that it does not have the capability to enhance the power whatever is given to it, but it has the capability to redirect the power to a particular direction. So if we want to specify the gain of the antenna, we have to use some reference antenna, and we have to use the reference antenna and say that with respect to this reference antenna, our antenna has the capability to direct the power in a particular direction. So which antenna we are going to use, based on that these unit of the gain will be different. If we are using an isotropic antenna, the unit will be in dBi. This I represents isotropic. If you are using a half wave dipole antenna as the reference, the unit will be dBd. This D represents the dipole. Let's see what is meant by gain in dBi. Here, the reference antenna is isotropic antenna, and we know that isotropic antenna is a theoretical antenna which radiates power equally in all the directions. So this is the radiation from an isotropic antenna. Here we can see that it is radiating equally in all the directions. So in case of an isotropic antenna, as the antenna is radiating equally in all the directions, we can say that the gain of this antenna is 1 in linear scale or 0 dBi in dB scale. But in case of a directional antenna, we know that it will be radiating differently in different directions. That means that it will be having directivity or gain different in each directions. So let's see how we can specify gain of this antenna using the scale dBi. So we know that gain of the isotropic antenna is 0 dBi as it is transmitting equally in all the direction. So to specify gain of this directive antenna in dBi, I am going to consider a horizontal cut of this plane to explain this one. So this is the radiation pattern in horizontal cut plane. You can see that with respect to an isotropic antenna, this is more directive and it has different gain in different directions. To specify gain with respect to an isotropic antenna, I am considering the isotropic radiation. We know that its value will be 0 dBi. So I'm going to consider this as 0 dBi. So here I can see that the main lobe direction is in this direction and its value is around 7.7 dB. And with respect to this isotropic antenna, we can say the gain is 7.7 dBi. As the isotropic antenna has the value of 0 dBi, it doesn't have much effect. Like we don't have to subtract anything as it is 0 dBi. So if you want to specify the gain at this position, it will be like minus 20 dBi. So based on that, we can specify the gain of the antenna in dBi. As this isotropic antenna is a theoretical antenna, it is considered as a universal benchmark for comparing the performance of different antennas. So we usually use dBi for comparing different antennas and specifying the gain of the antenna in manuals and everything. If we are going to specify the gain in dBd, the reference antenna is a half wave dipole. So this is the half wave dipole. So we have to specify gain of our directional antenna with respect to gain of our dipole antenna. So we know that dipole has an omnidirectional pattern. So it will be having equal power distribution along this plane and no power along these axes. So that is the omnidirectional pattern. So we have to, when we have to specify the gain of a directional antenna with respect to the dipole antenna, we will be considering this plane where the radiation is maximum. So we will be considering this blue circle plane where the gain is maximum. So along that plane, it has a gain of 2.15 dBi. So this value we are going to consider while calculating the gain of other directional antennas. So this will be our reference. So I'm going to consider the same antenna pattern to specify its gain in dBd. So here is the gain of the dipole antenna. Here you can see that its value is 2.15 dB. So this is our directional pattern and this is our uh, dipole antenna pattern. So if you want to specify the gain of this main lobe in dBd, we have to see this value and its value is around 7.77 and we have to subtract the dipole antenna gain, that is 2.15. So when you subtract the maximum value and 2.15, we will be getting the value of gain which is in dBd. So here we can see that this value is 5.62 dBd, that is the gain in dBd. So if you want to calculate the gain in dBd, what you have to do is you have to see the gain minus gain of the dipole antenna, that will give you the gain in dBd. We have seen how dBd is mainly calculated. So this the unit dBd was mainly used in old times, and you may have seen this scaling dBd in old manuals, and it is usually used nowadays by ham radio community, and for the broadcasting applications like FM VHF TV applications, this scaling dBd is used because dipole antenna forms the reference for these broadcasting applications. So if you want to specify the gain of any other antennas, we use dBd scaling. Let's see how to convert between dBi and dBd. We know that the dipole antenna has a gain of 2.15 dBi. So if you want to make any conversions, we can use that value and make the conversion. So if you want to calculate the gain in dBd, what we have to do is we have to take the gain in dBi minus 2.15. So we have seen this calculation earlier, and if you have to make the reverse calculation, gain in dBi, we can sum gain in dBd plus 2.15. This will give you the gain in dBd. So this is the main difference between dBi and dBd. So it mainly depends upon which reference antenna we are going to calculate the gain of the antenna. I hope you get some idea about dBi and dBd. Thank you so much for listening. If you find any of our videos useful, kindly like, comment, share, and subscribe. Thank you.